Hello, welcome to Econometrics. This is DC Economics. Today we are going to look on hypothesis testing. So we are going to cover what is hypothesis testing. We are going to cover also on what procedures of hypothesis testing, and we are going to cover also on how we use and we apply the hypothesis testing. So hypothesis testing, this is statistical analysis that uses data from sample to draw a conclusion about the population parameters or the population probability. So is where you put now the assumption about population parameters and then you test. For example, of hypothesis testing, a teacher believes that lack of discipline among students leads to mass failures or poor performance in school. This is an example of hypothesis testing whereby a teacher himself or herself comes with all logical guessing about the failures of his or her students. Also, another example, let's consider this. A doctor assumes 60% of patients who are suffering from malaria comes from rural urban areas. This is like a guessing maybe of a doctor actually seems to capture something that about why people are suffering from malaria. It's because maybe they are living far away. They don't have information. They lack some those medical treatment at early times, and many factors like that. So this is like a guessing, a logical guessing from a doctor. This is what we refer to as hypothesis testing. Now let's come and discuss the types of hypothesis testing. The first type is null hypothesis. Null hypothesis is the assumption that the event will not occur. We normally write in a simple way, sample mean is equal to population mean. This is referred to a null hypothesis. So this is the assumption that the event will not occur. So it's given as sample mean is equal to population mean, such that H naught such that beta 1 is equal to 0. H naught such that a beta is equal to 0. We have also alternative hypothesis. This is a logical opposite of null hypothesis. This is the opposite of null hypothesis whereby sample mean is not equal to population mean, and such that H1 such that beta 1 is not equal to 0. Now suppose you want to test a hypothesis that beta naught is equal to 0. Now choosing the estimator of beta naught estimated, now you use the sample data to obtain the estimate of B estimated, which is equal to, for example, we assume B estimated is equal to 1.00. Now, because B estimated is not equal to 0, now we tend to refer of the H naught such that beta 1 is equal to 0. So H1 such that beta 1 will be not equal to 0. Now because B estimated is not equal to 0, but the B estimated is equal to 1.00. Now, because of that fact, now we tend to reject out the null hypothesis. Since now the value of beta naught is equal to 0, so here now we reject the null hypothesis. So if the probability is less than 0.05, we reject the null hypothesis. by concluding that beta 1 estimated is equal to 1.00. So if the probability is less than 0.05, we reject the null hypothesis. Now, but if the probability is large, if the probability is larger than 0.05 or 5%, we accept the null hypothesis. You have to remember that the hypothesis that we test, is called the null hypothesis. So when testing the null hypothesis, we can make a correct or an incorrect conclusion. So when we test the null hypothesis, we can make a correct or an incorrect conclusion. So we make a correct conclusion when we reject the null hypothesis when it is false. But also we make a correct conclusion when we accept the null hypothesis when it is false. So when testing hypothesis, we can make two errors. When testing hypothesis, two errors can happen. We have type 1 error. Type 1 error, this occurs when we reject the null hypothesis when it is true. But also we have a type 2 error. This is also another error that may occur, whereby it occurs when we accept the null hypothesis when it is false. So the probability of making a type 1 error is called the size of the test. The probability of making a type 1 error is called the size of the test. So the power of the test is the probability of rejecting the null hypothesis when it is false. And of course, the power of test is given by taking 1 minus the probability of type 2 error. There are 3 alternative approaches that can be used in testing hypothesis. We may apply the first approach like level of significance. Second, we may apply also the confidence interval approach. We may apply also what is known as a p-value approach. Now, this time we'll focus only on looking on how we can use the level of significance approach in procedures of hypothesis testing. Now, let's come to procedures for hypothesis testing. The first procedure for hypothesis testing is to specify the null and alternative hypothesis. As I told you earlier, null hypothesis is a assertion about the values of one or more parameters. Now, it is given by taking sample mean is equal to population mean, whereby this assertion now is represented by taking out the h naught such that beta 1 is equal to 0. And we consider to take a sample mean is equal to population mean. And h naught such that beta 1 is equal to 0. So we have also the alternative hypothesis, whereby this is the opposite of null hypothesis, whereby we consider take the sample mean is not equal to population mean. And not only that, but also h1 such that beta 1 is not equal to 0. So alternative hypothesis is sometimes called two-sided or two-tailed test, because the alternative hypothesis allows beta naught to be greater or less than 0. So if the alternative hypothesis was written as either beta naught greater than 0, so or beta naught less than 0, so this will be one-sided or one-tailed test. So let's jump to another step known as deriving a test statistic and the sample distribution of the test statistic under the null hypothesis. So this is the second step that we need to know. So what is test statistic? Test statistic is a random variables whose values depends on the sample data, varies from sample to sample, and can be described by sample distribution. So the test statistic is a random variables whose values depends on the sample data, varies from sample to sample, and can be described by sample distribution. So when testing hypothesis about the values of single parameters in the simple linear classical linear regression model, the appropriate test is t-test. So t-test is one among the appropriate methods that we may apply when testing a hypothesis in connection to a simple classical linear regression model. So let's consider, suppose now we have our t-test, which is t calculated, which is our t tabulated given by bit estimated minus beta naught bracket divided by standard error of beta estimated, whereby in the right hand side we have t, we take the number of observation minus population parameter. So beta b estimated is equal to represent the estimate, and beta 1 represent the hypothesized value. Also, SE b estimated represents the standard error of the estimates, and N represents a number of observation, and K represents a number of parameters. Now, the third methodology also is to choose the level of significance of the test and find the critical value of the test statistic. So we choose the level of significance of test and find the critical values of the test statistic. We need to understand what is level of significance of the test. Level of significance of a test is the probability of making type 1 error. That is the probability of rejecting the null hypothesis when it is true. So when we reject the null hypothesis when it is true, or when you make a type 1 error, this is what refers to the level of significance of a test. So level of significance is represented by a symbol over there. So the first methodology is to use the sample data to calculate the actual value of the test statistic, whereby we take our t, which is equal to sample mean minus population mean, divided by square root of number of. So we take out our t statistic is equal to sample mean minus population mean divided by the number, square root of the number of observation. Or we may apply the z test, which is equal to sample mean minus population mean over standard deviation. So our x bar represents the sample mean, n represents the number of observation. Our u represents the population mean. So another methodology, which is the last one, we compare the actual value of the test statistic to the critical value. So from this last step, if the actual value, calculated value, is greater than or equal, if the actual value, the t calculated, is greater than the critical value, we reject the null hypothesis. So if we reject the null hypothesis, we say that the estimate is statistically significant or significant at critical value of a given level of significance. So if our t calculated is greater than the t tabulated, we reject the null hypothesis, and if the t calculated is less than the t tabulated, now we accept the null hypothesis. So as I told you, if we reject the null hypothesis, we say that the estimate is statistically significant at a given critical value of the level of significance. So, but if the t calculated appears to be less than the t tabulated, now we tend to accept the null hypothesis and a given level of significance, and the estimate now is statistically insignificant at the level of significance given. So this is how we analyze from the last methodology of hypothesis testing. So what only to capture on this, when t calculated is greater than t tabulated, we tend to reject the null hypothesis, and if the t calculated appears to be less than t tabulated, we tend to accept the null hypothesis at a given level of significance. Now after saying so, thank you for listening. This is DC Economics. I welcome you to subscribe my channel and don't miss on other session. Bye bye.